or the coil entering condition. And that is equal to, so T3 is equal to T2 plus Q of your outside air. Now here you're going to be using just your volumetric, okay? Divided by Q of the supply, which we determined just over there, times delta T. Again, if delta T was wrong, everything else is wrong, eh? So T2 we said was 24 plus the volume of the outside air was 0,5 divided by the supply, which is 1,376 times delta T, and delta T was 12,32 degrees Celsius, gives us a value of 28,476 degrees Celsius. And that value now we're going to now plot on the psychrometric chart. There's our chart, and it is 28,476. 25, 26, 27, 28, 476, so it's about 28.5, eh? 28,476. And you're going to draw that up to cross the line that is drawn between state point 1 and state point 2. So there we go. And where it crosses that line on where state point, the line between state point 1 and state point 2, you're going to put a dot and you're going to put a box around it, and you're going to label that state point 3. So that is going to be T3 is equal to 28,476 degrees Celsius. It's another point that you get. Okay, so you plot point 3 on the chart intersecting the line drawn between state point 1 and state point 2. Right, point number 11 of the recipe. You draw a straight line between state point 4 and state point 3. Right, so here we go. There we go. If we have a look on this thing, we've got, there's state point 4 over there, numbered. There's state point 3 over there, so it's a line between. So I'm going to do it in red so you can see it a little bit easier. Between there and there, you draw a line. Okay, so technically you've got everything No, wait, there's still one more thing I've got to do before we go any further. Before I tell you that you've now completed the chart. You haven't completed the chart yet, okay? Now, what is required is that, and we've got another color over here. Let me see. Now I'm just going to do it. I'm going to do it in black just to make it stand out. You then draw yourself the following. Okay. Again, trying to get all of your lines that you've drawn parallel with either the vertical or the horizontal lines. In this particular case, we're going to be drawing it parallel with the horizontal line. From state point 4, and I do it in dotted line over there, you can see it. In the dotted line, until it intersects with that line that you drew for T3, okay. Then you will draw a dotted line from T3 to meet up with that line, like that. So in other words, you can see there's a triangle I've just drawn. And this point over here, you can indicate a state point X, okay. Now we want to now find out how much energy is going to be put into the coil. Now remember, the coil, if you look at it over here, the coil worked between state point 3 and state point 4. Anything that happened to conditioning the air works between state point 3 and state point 4. Okay, so in other words, I've put it over there as 4 over there, but technically 4 would most probably be after the humidifier, really, in winter, if we were looking at a heater and a humidifier over there. So what we do now is we need to know how much energy is put into that section over there. So in other words, if we're just dealing with a cooling coil, we need to know how much energy is got to put into the cooling coil to affect the conditioning of the air on this side. If we in winter and we're using an element and we're using a humidifier, we need to know how much energy is got to be put into that system over there to give us our conditioned air into the conditioned space. So in this particular case, we're just looking at cooling. So we find over there that we are now going to be needing to know how much energy is transferred between state point 3 and state point 4. And if you look here, we've got this state point 3 and state point 4. So we can now read off of this chart using the enthalpy. What is the enthalpy at state point 3? We can read off the enthalpy at state point X. And we can read off the enthalpy at state point 4. So bearing in mind, because 3 to X is in the vertical plane, we are going to be dealing with latency. So that from 3 to X represents how much latent energy has got to be put into that coil to effect the conditioning. From X to 4 represents how much energy has got to be put in that coil to handle the sensible heat. So now, what we do is we then draw a line again as parallel as possible to those lines that are going down there. From point 3, we draw this line coming up over here like this. And we read off what the enthalpy is, and the enthalpy there looks very much like about 52, 55, 56, 57, uh, 55, about 56. So let's say that is 56 kilojoules per kilogram. That is H3. That is H3 is equal to that. Now we come to X over here. We see X conveniently lies on that line over there. And we can again just draw ourselves a line coming across. And we say that that is equal to 41, 45, 46, 47, about 47.5. HX, 47.5 kilojoules per kilogram. And similarly, we come here to state point 4. Lining up our ruler is as close as possible to parallel. And we draw it through point 4 and we say H4 is equal to, it's about 30.5. 30.5 kilojoules per kilogram. Okay, now at that point, you would have got maximum points for this chart. You would have a point there, you would have got a point over there, or a mark there and a mark there. You would have got a mark for your volume that you determined at 1. You would have got a mark for your volume determined at state point 4. You would have got a volume for a mark for your apparatus dew point. You would have got a mark for T4. You would have got a mark for T3. You would have got a mark for H3, HX, and H4. And then you would have got a mark, another mark, because you actually drew this incorrectly, because you drew that line from there to there. Invariably, everybody goes and does everything over here, but they don't actually draw in that line. That is the line. That's the most important one, because that's what we want to know, what happens over the coil. And the only way we can determine what happens over the coil is an understanding between point number 4, state point 4, and state point 3, which gives us those values. Without those values, you can't go any further. Okay. Now that you've got that, now we need to determine our energies. So, recipe number 12. Determine the energy to provide for sensible heat removal. And that is going to be, the energy for your sensible heat is going to be equal to the mass flow of your supply times H at X, enthalpy at X, minus the enthalpy at 4. Remember again what I said? Between HX and H4 is in that plane, which is the horizontal plane, which is the sensible heat. So you're dealing with the correct thing, multiplied by 1 divided by the specific volume at 4. Why do I add that in over there? I add it in because we don't work with volume. We work with we don't work in cubic meters per second. We work in mass flow, okay, which is kilograms per second. Beg your pardon. So you could also just say Q supply divided by the volume over there. I just added in as an inverse, but whatever floats your boat. So that is equal to, we said Q supply was 1,376 multiplied by HX. HX we said was 47.5